Hi, let's calculate this definite integral. And for this calculation, we will use a formula from this part of board. First of all, here we have square root, and we need to do a substitution. First of all, from here, I can obtain this line. I will explain why am I doing it. Minus x squared plus 2x plus 1. Plus 1, well, from here actually. Let's see, if we will write this line here, and here will be 3. Let's see, minus x squared we have, minus 2x we have, minus 1, 3 minus 1 gives us 2. So we need to plus 1 here too. So our line here in our square root, we can write like this. Let's do it. Integral from minus 1 to 1 of square root 3 plus 1 gives us 4, then minus, and this line x squared plus 2x plus 1. It's a little trick. And here we can use a formula. Let's, write it here. A plus b squared gives us a squared plus 2ab plus b squared. So it's a well-known formula, and a here is x, b here is 1, and 2 multiplied by x, and actually here is multiplication by 1. So this part of our line we can rewrite and obtain, well, integral of square root, I lost dx, it's a bad idea to do it, so 4 minus, and here will be x plus 1 squared dx. Well, we did it, but it actually doesn't look any simpler. And now we need to use substitution. Actually, we need to use here trigonometry, because we have square root, we have number, and minus or maybe plus x, or function with x like this, squared. So what should we do? We should let our x plus 1 like a trigonometric function of, for example, t. Here will be sine of t. But if I put here a sine, let's see what it will be here. 4 minus sine squared. But why we use trigonometry here? We use it because we know from trigonometry formula sine square of x plus cosine squared of x gives us 1. And if here will be sine, let's see, sine squared of x gives us 1 minus cosine squared of x, or cosine squared of x gives us 1 minus sine squared of x. So if here we will have 1 minus sine squared, it gives us cosine squared, and we can calculate the square root of it. So, but here we have 4. So here we need 4 too. How can we find it for here, we should put 2 here. And our substitution, it's our substitution. X plus 1 equals 2 sine of t. Well, also we need to change, for example, x1 and x2 and find dx. Let's do it. If x1 equals to minus 1, well, here should be, when we will do our substitution, here should be t. But how we can find it? Let's see. Minus 1 plus 1 gives us 0. And we obtain this line. 0 equals to 2 sine of t1. And from here, sine of t1 is 0. So t1 will be equal to 0. Because of arcsine, from here arcsine of 0 gives us 0. Let's do the same for x2. x2 equals to 1. So how we can find t2? So let's see. 1 plus 1 gives us 2. To here and to here we can delete this line by 2, and we will obtain sine equals to 1. So sine of t2. So to find t2, we need to use function arcsine of 1, and it gives us pi divided by 2. And then we need to find dx. So let's see here. From here, we obtain d of x plus 1 differential, equals to differential of 2 sine of t. And it gives us dx equals to, let's see, derivative of sine gives us cosine, and 2, of course, will be here, 2 cosine of t dt. So it's our dx, and we can now use our substitution. Pay attention that you need to substitute these numbers too. It's important. So we will have an integral from, let's see, from 0 to pi divided by 2. Then we will have this square root. Here will be 4 minus x plus 1 gives us 2 sine of t. 2 squared gives us 4. And here will be sine squared of t. And 4 and 4. We wanted it, and we did it. Then dx. dx equals to 2 cosine of t dt. Well, then we can write 4 from here and here, well, gives us 2, and 2 multiplied by 2 gives us 4, and I write it in front of our integral from 0 to pi divided by 2, and then will be square root of 1 minus sine squared of t multiplied by cosine of t dt. This line, let's see, equals to cosine squared of x. So here will be cosine squared of x, and then we apply this function square root and actually then multiply it by cosine, and we will obtain cosine squared. So let's write it. Cosine squared dt. Actually, in previous videos I calculated this integral, but let's do it again. So again, we need to use trigonometry because of here we have power of 2 and we want to have power of 1. So what should we do? Let's see. If we write cosine of 2t, we know that cosine of 2t equals to cosine squared of t minus sine squared of t. And of course, also we know that sine squared equals to 1 minus cosine squared. So here will be minus 1, and minus multiplied by minus gives us plus cosine squared. So we will obtain 2 cosine squared of t minus 1. And here is our cosine squared. So let's write it. Cosine squared of t equals to, let's see, cosine of 2t minus goes here and gives us plus 1 and divided by 2. So cosine squared equals to this function. Well, let's use it in our integral and rewrite our integral like this. Cosine of 2t divided by 2, I split it into two parts like this. Cosine of 2t divided by 2 plus 1 divided by 2. Here dt. Then I need to split this integral into two integrals. Let's see. We need to divide 4 by 2 and we will obtain 2. And we can write these 2 here. So as a result, we will have integral of cosine of 2t d 2t. These 2 from here. 4 divided by 2 gives us 2, and these 2 goes here. Then plus integral of 4 divided by 2 gives us 2, and here will be 1, so dt. Next, we can calculate our integrals. Here will be sine. Here we have 2t and 2t. It's okay. So we need to calculate. That's all. Sine of 2t. And here will be 2 plus 2t. Of course, from 0 to pi divided by 2. And now we need to use this formula. So now we are here, and our next step will be take pi divided by 2 and put it here and here, then write minus and do the same with 0. So let's do it. Use this formula. What we will obtain? Sine 2t. 2 divided by 2 gives us pi. Sine of pi equals to 0. Then plus 2 multiplied by p divided by 2 gives us pi divided by 2 gives us pi. Then minus sine of 0 gives us again 0, and minus 2 multiplied by 0 gives us 0. So 0, 0, 0, and our result is pi.